Hi students. Until now, in the previous lessons, we've studied about electric current, we've studied about what causes electric current, electric potential. In this chapter, we will learn in detail about circuits. We will learn about circuit diagrams. We will understand the different symbols, used to represent the different circuit elements on paper. Let's learn about circuits in this chapter. The first thing we need to understand, of course, is what is an electric circuit. An electric circuit is a closed path that shows charge flowing continuously in a loop. It has a source of charge from which charge keeps flowing because of the potential difference created in the circuit. Now this seems to be quite a complicated definition. What exactly is an electric circuit? An electric circuit is not complicated at all. It is simply a closed path in which charge keeps on flowing regularly. The charge flows because of the potential difference between 2 points in the circuit. That's it. That's what a circuit is. A closed loop through which charge keeps flowing because of potential difference. This diagram you see on your screen represents a circuit. There's a battery and there's a bulb. You can see that charge keeps flowing out from the positive terminal of the battery and the charge keeps coming in through the negative terminal of the battery. So this is a simple circuit. Of course, the potential difference here is maintained across the circuit by the battery. The chemical reactions in the battery create potential difference between 2 points in the circuit. It is this potential difference that makes the charge flow throughout the circuit. The different objects connected in the circuit are called circuit elements. So the bulb is a circuit element. Most circuits have this arrangement. There's the battery, and the battery is connected to circuit element 1, circuit element 2 and circuit element 3. Understood? This is a basic series circuit. As you can see, each circuit element is arranged in series, one after the other. The battery creates the potential difference across all the circuit elements, and that is the reason charge flows through all the circuit elements. So now that we've understood what a circuit is, and we've looked more into detail about how a standard circuit looks like, let's come to the crux of this chapter. Electric circuit symbols. You see, when we represent an electric circuit on paper, we cannot always draw detailed diagrams. We cannot, for example, draw a battery, or we cannot draw a bulb. We cannot draw wires in detail. So we use different symbols to represent real life circuit elements on paper. For example, we use a symbol for an electric battery. We use a symbol for an electric bulb. Understood? These symbols help us draw circuits easily on paper. It is these symbols that we are going to learn about in this chapter. The first circuit element we learn about is an electric cell. An electric cell is simply the device which creates a potential difference across 2 points in a circuit. The symbol for an electric cell is this. As you can see, there is a large line followed by a shorter line. The large line represents the positive terminal of the cell, so we add a plus next to the large line. The small line represents the negative terminal of the cell, so we add a minus near the small line. The large line represents the portion of the cell which has less electrons, and the small line, which is at lower potential, represents the portion of the cell which has excess of electrons. Of course, a real cell does not look like this. This is how a real cell looks like. Understood? So you can see that this is the representation of a real cell on paper. You must remember this symbol. An electric battery, on the other hand, is basically a combination of cells. You see, cells have a limited potential difference creating capacity. So we combine different cells when we want a greater potential difference in the circuit. So therefore, the symbol of a battery or a combination of cells is like this. As you can see, a real battery looks as shown in this figure. Underneath this covering that you're seeing, the yellow and silvery covering, there are many small cells shown. Understood? So many cells are combined together to form a battery. In this symbol here, you can see one cell, the second cell, the third cell, and so on. Isn't it? Interestingly, the potential difference of the entire battery is the sum of the potential differences of each of the individual cells. So if these are all 2 volt cells, 2 volts, 2 volts, 2 volts, then the final potential difference created by the entire battery will be 2 plus 2 plus 2, that is plus 6 volts. In the symbol for a battery, you can see many long lines and short lines, next to each other. You can also see that plus is written only of the leftmost end of the battery and minus is written only at the rightmost end of the battery. So this is the symbol of a battery, which is simply the combination of cells. The next symbol we will study is the symbol for a switch or a plug key. You see, what happens in reality is that we use a device called a plug key. Here, this picture on the right shows a plug key. In this plug key, you have to insert a key. When you insert the key, the circuit is complete. But when you remove the key, the circuit is incomplete. Understood? When the key is inserted, electric current flows in the circuit. But when the key is removed, electric current stops flowing in the circuit. So the purpose of a switch or a key is basically to stop or start the flow of electric current in a circuit. When the key is removed from this plug key system, we say that the switch is open. Understood? Or we say that the key is open. After all, this is the condition in which the electric current is not flowing because a key has not been inserted into this hole. Understood? It is when a key is inserted into this hole that the current starts flowing. The symbol for a plug key or an open switch is this symbol. Here you go. As you can see, there are 2 brackets and there are 2 lines beside the brackets. So this symbol here represents an open switch in a circuit. On the other hand, this symbol here, this one, represents a closed switch. As you can see, this dot between the brackets tells us that the switch is closed or the key has been plugged. You can see here that a key has been inserted into the switch, isn't it? The insertion of this key tells us that electric current is flowing in the circuit. The next circuit element we'll study is a wire joint. Sometimes what we have to do is we have to join some wires in a circuit. We want something in the shape of a T, something like this. So basically we want 3 wires to come out from a point. In that case, we represent a wire joint by this symbol. We simply draw 3 lines in the shape of a T and we draw a small dot at the intersection of the 3 wires. In reality, this is represented by the picture shown. As you can see, there are 2 wires here coming out of 1 wire, isn't it? And these wires have been joined by a tape. This same picture is represented by the symbol shown on the left using the T symbol. The T that is inverted. Wires crossing without joining is the next circuit element. You see, sometimes wires have to cross each other without joining the other wires. For example, there may be a wire that's going from point A to B. There may be another wire that's going from point C to D. Now these wires may cross each other, but they are not joined. The wire going from C to D is a separate wire. It is just going above the wire going from A to B. Understood? So in such cases, the wires are represented by this symbol. As you can see, one wire is a straight line and the other wire forms a semicircle at the very point where it crosses the first wire. This semicircle tells us that these 2 wires are not intersecting. Understood? If there was no semicircle and if there was a straight wire, that would mean that these 2 wires are intersecting and that current can flow from one wire to the other. Here, this semicircle indicates that these 2 wires are different. Of course, in real life, this happens like this. As you can see, there's a black wire and an orange wire, and the orange wire is moving above the black wire. Both the wires are not joined to each other. Understood? So this is the real picture of 2 wires crossing each other without joining. Yet another important component in electric circuits is, of course, our good old electric bulb. This is the symbol of the electric bulb. The electric bulb has something called a filament. We'll learn about a filament later. This symbol here represents the filament in an electric bulb. If anytime take out an electric bulb and look at it carefully, you will see wires arranged as shown in this symbol inside the electric bulb. So this is how an electric bulb is represented, by these curved wires. Of course, this is a real electric bulb on the right side, you can see. One important circuit element which we haven't yet studied about is called resistor. We will study about resistors in the next lesson. A resistor is represented like this. In real life, a resistor is represented like this, as shown on the right. Now you might wonder, what exactly is a resistor? For now you can understand that a resistor basically resists the flow of electric current. Sometimes we want that less current should flow, through a circuit, or we want that more current should flow in a circuit. We vary the resistor value to vary the current in the circuit. This might seem complicated just now, but we will learn in detail about this concept in the next chapter. For now, you must remember that the symbol for a resistor is these zigzag lines shown on the left, and a real resistor looks like this. There is another complicated circuit element that we will learn about in the next chapter. It is called rheostat. A rheostat is basically a variable resistor. So the advantage with the rheostat is that it can provide different resistances to current using the same instrument. So the same rheostat can cause different currents to flow in the circuit by offering different resistances to the current. This is the symbol for a rheostat. So basically the symbol for a rheostat has zigzag lines, and there's an extra bent arrow over one of the zigzag lines. This is the symbol for a rheostat. In reality, a rheostat looks something like this. This knob here, this black knob, is moved to the left or moved to the right to increase the resistance to the flow of electric current, or to decrease the resistance to the flow of electric current. Of course, we will learn in detail about a rheostat in the next chapter. The next electric circuit component that we will study about is the ammeter. You already know that an ammeter is used to measure electric current. This is how an ammeter is represented in an electric circuit. Basically, there is a circle, and there are two lines at the left end and the right end of the circle. An A is written inside the circle. A plus sign is mentioned, on one side of the circle, and a minus sign on the other side of the circle. The plus sign is connected basically to the positive end of the battery, and the minus sign is connected to the negative end of the battery. Understood? So you must remember, which sign is connected to which end of the battery. Of course, a real ammeter looks something like this. As you can see, it shows the reading in amperes. Let's now move on to the voltmeter. As you know, the voltmeter measures the voltage in a circuit. This is the symbol for a voltmeter. Again, just like in the case of an ammeter, there's a circle connected on both ends by lines. There's a plus sign and a minus sign on either side of the circle, and there's a V written inside the circle. V for voltmeter. The plus sign is again connected to the positive terminal of the battery, and the minus sign is connected to the negative side. Here's a real voltmeter, of course, which gives its reading in volts. So you must remember all these symbols. After all, you will be using them when drawing circuit diagrams. Now that we've understood so many symbols related to circuit elements, let's move on and solve a problem.